Hello children, hope you guys are fine and are staying safe at home. So welcome to the online class once again. Remember what we have discussed in our previous class. So before we enter into the chapter, today's chapter, I would like to conduct one small test for you. I know you guys are not with me now, but then just try to see the questions and try to recollect the answers on your own. So the first question, to draw water from a well, we have to dash at the rope. So I hope you guys know this answer. So the options are option A pull, option B throw, option C push, and option D none of the above. So as I discussed earlier in our previous class, we discussed mainly about force, right? So for a force, we either require push or pull, right? So shall we find out the answer? So what is this actually? To draw water from a well. So how will you draw water from a well? Which type of force will you apply? Push or pull? Okay, let's see the answer now. So it's not throw, obviously we cannot throw. Okay, so that you can draw water from a well. Okay, so push and none of the above is also not the correct answer. So what is the correct answer actually? The correct answer is pull. So we have to pull the bucket from the well. If you want to draw water from the well, you have to apply which type of force? You have to apply pull. You have to pull the bucket from the rope. Okay, using the rope. Now the second question is, to move a loaded trolley, we have to dash it. Now again, the same type of question it is. Which force will you apply, push or pull? The correct answer is actually push. So if you want to move something, move an object, move a trolley. So which type of force will you apply? Will apply push. And the question number 3, the north pole of a magnet dash the north pole of another magnet. So as I already said, same poles, what will happen? Will it attract or will it repel? So it will obviously repel. So repel, or we can also call it as it is pulling away. Okay, so it will move away from each other. Okay, so that is what we refer it as repel. So same poles will not attract, it will actually repel from each other. Move on to the concept, let's do a quick recap of what we have learned in the previous class. We discussed about in science, a push or pull of an object is called as force. So what is the definition of a force? It is nothing but simple push or pull of an object. Okay, and as I said already, for a force to come into play, how many objects must be there? At least two objects must be there. At least two objects must come into contact. Then only we can generate or we can apply some force. Otherwise, only having one object, there will be no force. Okay, so if I keep something, any object, if you say, if you keep a normal water bottle somewhere on the table, so until and otherwise I don't apply any force to the water bottle will not move. It will remain intact. It will remain static on its position. So any object will not move until some sort of force between two objects are getting connected. Okay, and the third one, what I said, an interaction of one object with another object results in a force between the two objects. So when the force comes into play, as I said just now, so one object has to undergo interaction with another object. So somehow one object has to touch another object or interact another object, then only force will generate, force will come into play or come into existence. Okay, so I hope you guys remember what we have learned in the previous class. So now let's continue part 2 of the chapter, force and pressure. Okay, more interesting. So in today's class we are going to learn more about forces. So in the beginning, I mean in the first class, I just gave you an introduction about what is a force and how a force can be applied. That only I discussed. Now in today's class, we can able to understand the different way the forces behave or act with each other. Okay, that is our main objective of today's class. Okay, let's move on to exploring forces. Let us try to learn more about forces. So before we learn about learn more about forces, I'd like to throw you a simple question. Have you ever seen a game of tug of war? So I hope it is everybody's favorite game. Even you would have played during your leisure time or with your friends, right? So a tug of war will look something like this, right? So here there will be two different teams of people. Okay, so they will try to pull the rope in their direction. That's how a tug of war is being played. So what actually happens, members of both the teams, they will try to pull the rope in their direction. So the one who actually pulls harder, okay, the team, the member of the team, the people who try to pull the rope harder, and they only will actually finally wins the game. The one who tries to push, they try to pull the rope harder and bring the other team towards them, they only will win the game. Okay. Now here, what actually you observe? So here some sort of force is getting enacted on the rope, right? So here there is only one man standing, but here four people are standing. So there will be a variation in force. So this man, if he has to pull the rope, he has to apply greater force, right? But these guys, because they are larger in numbers, four members are there in one side, so they do not have to apply large force. Even with a little force also, they can easily try to pull the rope towards themselves. So that some sort of variation is there. So by quoting these as an example, I would like to explain you in today's class how a force can be applied, how a force can be enacted in different objects. To explain about that, let us try to understand a small activity. Okay, if you guys are in the class, I would have done this activity. Since this is not a live class, this is just an online class, so you try to analyze by seeing this question, okay, and try to apply it in your home. So imagine, choose a heavy object like a table or a box. Most probably you will have a table in your home, right? So just try to select a table which you can move only by pushing hard. So you try to move by pushing hard, something like this, okay? So in the beginning, when you try to push, you alone try to push the table, okay? So that you can able to understand how much force is required to push the table. Now second time what you do, try to push it all by yourself. First you have to push it all by yourself, and you need to understand whether you can able to move it or not. If it is too heavy, you cannot able to move, you won't be able to move. So if it is not too heavy, if it is too light, then you can easily move it, okay? So that you need to just analyze it, okay, whether I can able to move it or not. Now ask one of your friends. Now since you don't have friends at home, so you can ask your family members, your father or mother or your brother, whoever is there. You can get the help from them to push it in the same direction. So something like this, okay, like how these guys are pushing, okay, the same way you can ask help from your brother or sister or your father or mother, okay, so that they can also move along with you. In case if you're not able to move, okay, or you are finding difficult to move the table, you can get the help from your parents or your friends or your brother and sister, so that they can also join with you to move the table in the same direction. Now you just try to understand, is it easier to move now? So before, when you were trying to move alone, you were finding very hard to move this table, right? Because your weight and the table's weight matters. So if a table has got more weight than you, okay, then it will be very hard for you to move the table from one place to another place. Now since you have added one more person, okay, and both of them are trying to apply the force, since the weight will be added, right, another person's weight will also be added, and when he also applies the force, then what will happen? You can able to easily move the table from one place to another place. The reason being, the weight of the table reduces, or we should not term it as weight actually. In physics, we term it as momentum. In physics, we term it as momentum. So the momentum of this object reduces when you add more people and when you try to apply the force in the same direction. And when you try to apply the force in the same direction, your force plus another person's force will also get added to it. Okay, before you are alone, try to push the table, right? So only your force was being applied over there. But when you add another person, what will happen? His force also will be added, right? So it will be easy for you to move now. So when you just remember, when you try to push any object, so when you add more force, when you add one more person, or when you add one more object to push in the same direction, then what you are doing actually, you are adding more force. Okay. Now imagine another where this activity can be done in another way. Okay. Next, push the same object, but ask your friend or your brother or sister, whoever, to push it from the opposite side. So before, what you were doing, you were trying to push in the same direction, but now you are trying to push in the opposite direction. So that, does the object move now? Do you think this object can be moved now? You cannot. Why? What will happen actually? The reason being, when you apply, as I said already, when you apply the force in the same direction, the force will get added up and you can able to easily move in one direction, or the direction where you want the object to move. But now, since you are trying to apply force, you are applying force, but you are trying to apply the force in the opposite directions. Opposite direction in the sense, even this person will try to move this object into maybe right side. So this person is applying the same force in the opposite direction, right? He wants this table to move into the left side. So what will happen when both the person try to apply the force in opposite direction? The force will get nullified. Nullified means it will become zero. So, or it may happen something like, if somebody, imagine this person is applying more force than this person, then what will happen? This object will slightly move towards this person. Okay, that's it. That's what will happen. But when both the forces are equal, in the opposite direction, then at that time what will happen? Both the forces will get nullified. Okay, so you can just try doing this activity to determine how the forces are being applied in the same direction and how it acts. And when I apply the same force in the opposite direction for a same object, okay, and how it actually enacts. So both these things you try to do this activity at home and try to find out this. If you want to understand, so what do these examples suggest about the nature of force? So if you try to apply force on the same direction, it will get added to one another, which means the force will get added up to one another. Okay, but whereas if you try to apply the force on the opposite direction, the net force acting on it is the difference between the two forces. So you can easily calculate the net force by calculating this man's force and this man's force, and you have to subtract it. Okay, so for example, if this man's force I can consider it as F1 and this man's force I can consider it as F2. So for the example, if this man is applying one force, say 10 Newton, and this man is applying a force 5 Newton, so 10 minus 5 will be how much? 5 Newton. So the total force which is acting on this table you can easily calculate as by subtracting both the force, and you will get one answer. Okay, if both the forces are same, 5 and 5 Newton means then it will become 0. Okay, so this you need to understand. See, let's try to think. Just now as I said, does it mean that the net force on an object is 0 if the two forces acting on it in the opposite directions are equal? So as I said already, so these two persons who are applying force, if they apply the force in the opposite direction, same force in the opposite direction, then the net force will become 0. So as I said, F1 is 5, F2 is 5 means 5 minus 5 will be automatically 0 Newton. So the force will automatically come to 0 if both the first persons try to apply the same force in opposite direction. Okay. Understood up to this. You need to understand one more thing. So we learned that a force could be larger or smaller than the other. So as I said already, not everybody who is applying the force will not be same. Okay, some person will apply greater force, larger force. Some persons will apply smaller force. So there will be a variation in the force. Okay, for example, my weight is just a 55 kg assume, and another person's weight who is a bodybuilder, his weight is some 80 kilogram. Okay, so a person who is pushing the table 80 kilogram, he can push the table easily because he has more strength to apply the force, right? So the force which he is applying will be more. But if I apply the force, okay, the force will be half of that what he is applying. And if we both together apply, then what will happen? Obviously, we can easily move the table, right? So, how the strength of the force is determined? So, the strength of a force is usually expressed by its magnitude. So, magnitude is nothing but, we can say, it is nothing but the weight of an object, okay? So, the way with which the object is determined, okay? I mean, the force is determined. So, the force is determined using the strength. That is by calculating the magnitude of an object. For example, I'll tell you. Now consider this as an example. Now this is a bus carrying different passengers over there. Some 4 passengers are sitting. So this bus will have got some magnitude. Okay, so this bus carries not only the weight of the bus plus the 4 passengers who are sitting inside the bus. Now if this man is trying to push this bus, if he wants to push this bus, or if he wants to move this bus from in a particular direction, he has to apply greater force. Why? Because the magnitude of this bus is more. Okay, so the people who are sitting inside as well as the weight of the bus is there. So he has to apply greater force. The strength of the force will vary now. So he will find very hard to move this bus. So the same, if for all these 4 members come outside and when they try to push this bus, it will be easy for the bus to move. The reason being the magnitude of this bus will be reduced, right? The weight of the bus will be automatically reduced. So as a result, even at a smaller force, even if at a smaller strength of force, we can easily move this bus. Okay, now let us consider few more examples now. Imagine one more thing, not only magnitude, even direction also plays a very important role for a force to act. Okay, magnitude is there, but the direction where you are applying the force is also very important, because in the previous activity also we discussed in the first example, a table was pushed in only one direction, same direction. So it was easy for us to move. When 2 persons also move, it is easy for them to move. But in the second instance, when they try to push the same table in the opposite direction, then they both were finding difficult to move the table, right? So a force also a force also related to the direction, not only with the magnitude. A force varies along with magnitude as well as direction. So if the direction or the magnitude of the applied force changes, its effect also changes. The way the direction change or a magnitude change, based on that only the force will also change, its effect will also change. For example, now consider this is a rugby ball, right? So for a rugby ball to hit properly, okay, I have to keep my foot in this angle, and then when I apply the force to hit in this direction only, I can able to hit this rugby ball to a longer distance. Otherwise, if I try to keep my foot flat and try to kick this ball will not move easily. You're getting my point? So here the magnitude of this ball, not only the magnitude, even the direction with which the player is trying to hit this ball also depends on the force with which we are enacting. Okay, the same way, if you take this baseball or a cricket match, okay, if a batsman has to hit the ball in a particular direction, he has to first denote the speed or the magnitude of the ball, where the ball, how the ball is coming, and based on that, if we exactly connect the ball with a proper direction, and based on that direction only it will move easily. So if this man has to hit in this direction, means he has to keep the bat properly and try to hit or try to lift the ball, then only based on the direction and the force which he is applying, the ball will move away. Otherwise, if the same ball, if the same batsman, if we try to connect this ball here, then the ball will not move easily. It may fall in the same place, or it may move only for a particular distance. Okay, so the force, the effect of force clearly depends on, or we can say the effect of force is directly proportional to magnitude and direction. So both plays a very important role in a force to enact. So up to this I'll stop today's session. So let's do a quick recap on what we have learned. We learned that force applied on the same direction add to one another. This is very important, you need to remember. Okay, so if you apply the force in same direction, the force will get added up. So if you apply the force in opposite direction, so the net force you can calculate by calculating the difference between the two forces. Difference means what? Subtraction. Okay, then the strength of the force can be determined only by its magnitude, not only magnitude, even direction. Okay, so that is also very important. Let's do a quick assessment. So try to find out the answer on your own and make a note of it in your classwork note. Okay, the first question is, what happens when a force is applied on an object in the same direction? So I already even I have given the answer in recap, so you can find out or you can try to answer it on your own. Second question, define magnitude of a force. Okay, so these two questions you try to find out the answer. Now there is a homework for you, home fun actually. So this home fun is nothing but identify whether the magnitude and direction is applied on all these forces as given in the picture. So you need to just identify whether both the magnitude as well as direction is applied on all these pictures. Okay, whether the magnitude is applied or not, or whether the direction is applied or not. So you need to find out and answer it. Okay, so with this I'll wind up today's session. I hope you guys would have enjoyed today's class. Okay, in case of clarifications, you can refer this video again, and you can even throw your questions or queries, okay, in the group. Okay, so thank you children, have a great day.